The question of whether to use arc fault circuit interrupter or AFCI breakers to protect smoke detectors is a complex one, with valid arguments on both sides. In favor of AFCI protection are several key points. Firstly, reduce fire hazards. AFCI circuit breakers are designed to detect and interrupt arc faults, which are a common cause of electrical fires. By protecting smoke detectors with AFCI breakers, the risk of a fire originating from an electrical fault in the smoke detector circuit is reduced. Secondly, improve detection capabilities. Smoke detectors need power to function correctly. An AFCI breaker can protect the power supply to the smoke detector, ensuring that it remains operational even during an electrical fault. Thirdly, comply with building codes. Many building codes and electrical standards now require smoke detectors to be protected by AFCI circuit breakers. Adhering to these requirements helps ensure that a property meets current safety regulations. However, there are also compelling arguments against using AFCI protection for smoke detectors. Firstly, increased maintenance costs. AFCI circuit breakers are generally more expensive to purchase and install compared to standard circuit breakers. Moreover, they may require periodic testing and maintenance to verify they are functioning correctly. Secondly, false positives. AFCI circuit breakers are highly sensitive to electrical faults, which can sometimes lead to false positives. This can result in unnecessary power interruptions and inconvenience for occupants. Thirdly, redundancy. Most smoke detectors are equipped with battery backups that provide power during a power outage. In this case, AFCI protection may be considered redundant, as the battery backup would still power the smoke detector if the AFCI breaker trips. When it comes to combination carbon monoxide, or CO, and smoke detectors, there are some specific concerns to consider. Firstly, potential for interference. AFCI circuit breakers use electromagnetic signals to detect arcing faults. In some cases, these signals can interfere with the normal operation of combination CO and smoke detectors. Secondly, loss of protection. If an AFCI breaker fails and the battery backup in the CO and smoke detector also fails, the detector will be without any power source. This could seriously compromise the safety of the occupants in the event of a fire or carbon monoxide emergency. In conclusion, deciding whether or not to protect smoke detectors with AFCI circuit breakers requires carefully weighing the potential benefits of enhanced fire safety against the potential drawbacks of increased cost and the possibility of false positives. It's essential to consult local building codes and electrical standards and consider the specific circumstances of each property, including the type of smoke detectors that are being used. In Southeast Florida, the specific requirements of Palm Beach County, which mandate AFCI protection for smoke detectors, reflect a local emphasis on enhanced fire safety. However, the concerns raised about redundancy and potential interference with combination CO/smoke detectors are still valid and warrant careful consideration. To delve deeper into the technical aspects of AFCI breakers, let's explore how they function and the types of faults they are designed to detect. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults. An arcing fault is an unintentional electrical discharge between two or more conductors. These faults can generate intense heat, which can ignite surrounding materials and cause a fire. There are two main types of arcing faults: series arcs and parallel arcs. A series arc occurs when there is a break or discontinuity in a single conductor. This type of arc is often caused by damaged or deteriorated wiring, loose connections, or broken wires. A parallel arc, also known as a line-to-line or line-to-neutral arc, occurs when there is an unintended connection between two conductors with different potentials. This type of arc is often caused by damaged insulation, moisture, or conductive materials bridging the gap between the conductors. AFCI breakers use sophisticated electronics to detect the unique characteristics of arcing faults. They analyze the current and voltage waveforms in the circuit, looking for patterns that indicate the presence of an arc. These patterns include irregular current fluctuations, high-frequency noise, and distorted voltage waveforms. When an AFCI breaker detects an arcing fault, it quickly trips, interrupting the flow of electricity in the circuit. This helps to prevent the arc from generating enough heat to ignite nearby materials and cause a fire. AFCI breakers are designed to be more sensitive to arcing faults than traditional circuit breakers. Traditional circuit breakers are designed to protect against overloads and short circuits, but they may not always detect arcing faults, especially low-level arcs that don't draw enough current to trip the breaker. There are two main types of AFCI breakers: branch/feeder AFCI breakers and combination AFCI breakers. Branch/feeder AFCI breakers are designed to protect the entire branch circuit, including the wiring, outlets, and appliances connected to the circuit. Combination AFCI breakers provide the same level of protection as branch/feeder AFCI breakers, but they also include additional circuitry to detect parallel arcs. Parallel arcs are more difficult to detect than series arcs, so combination AFCI breakers are often recommended for use in areas where parallel arcs are more likely to occur, such as in bedrooms and living rooms. The National Electrical Code, or NEC, contains specific requirements for AFCI protection in residential occupancies. The NEC requires AFCI protection for all branch circuits that supply 120-volt single-phase 15 amp and 20 amp outlets installed in bedrooms, living rooms, dining rooms, family rooms, recreation rooms, dens, libraries, and similar rooms. The NEC also requires AFCI protection for branch circuits that supply arc fault circuit interrupter protection for branch circuits that supply dwelling unit kitchens and laundry areas. When selecting AFCI breakers for smoke detectors, it is important to choose breakers that are specifically listed for use with smoke detectors. Some AFCI breakers may not be compatible with certain types of smoke detectors, and using the wrong type of breaker could cause nuisance tripping or even damage to the smoke detector. It is also important to follow the manufacturer's instructions for installation and testing. AFCI breakers should be installed by a qualified electrician, and they should be tested periodically to ensure that they are functioning properly. In addition to AFCI protection, smoke detectors should also be installed and maintained properly. Smoke detectors should be installed on every level of the home, including the basement, and they should be tested monthly to ensure that they are working properly. Smoke detectors should also be replaced every 10 years, or sooner if they fail a test. Battery-powered smoke detectors should have their batteries replaced at least once a year, and it is a good idea to replace the batteries when you change your clocks for daylight saving time. When considering the arguments against AFCI protection, it's crucial to examine the potential for false positives in more detail. False positives, or nuisance tripping, can occur when the AFCI breaker trips even though there is no actual arcing fault present. This can be caused by a variety of factors, including electrical noise, faulty appliances, and even the normal operation of some electronic devices. Electrical noise can be generated by a variety of sources, including power line disturbances, radio frequency interference, and electromagnetic interference. This noise can sometimes mimic the characteristics of an arcing fault, causing the AFCI breaker to trip. Faulty appliances can also cause false positives. Appliances with damaged cords, loose connections, or worn-out components can generate electrical noise that can trip the AFCI breaker. Some electronic devices, such as computers, printers, and televisions, can also generate electrical noise that can cause false positives. The sensitivity of AFCI breakers can also contribute to false positives. AFCI breakers are designed to be very sensitive to arcing faults, but this sensitivity can also make them more prone to tripping due to electrical noise. To minimize the risk of false positives, it is important to ensure that all electrical wiring and appliances are in good condition. Damaged cords should be replaced, loose connections should be tightened, and worn-out components should be repaired or replaced. It is also important to avoid overloading circuits and to use surge protectors to protect against power line disturbances. If you experience frequent false positives with an AFCI breaker, it is important to consult with a qualified electrician. The electrician can help to identify the cause of the false positives and recommend solutions, such as installing a line filter or replacing the AFCI breaker with a less sensitive model. Regarding the redundancy argument, while battery backups are a standard feature in most smoke detectors, their reliability can vary. Batteries can degrade over time, and their lifespan can be affected by factors such as temperature and humidity. It is important to test smoke detector batteries regularly and to replace them as needed. In addition, some smoke detectors may have limited battery backup capacity, which may not be sufficient to provide adequate protection during a prolonged power outage. In the context of Palm Beach County's requirement for AFCI protection, it is important to consider the potential consequences of an AFCI breaker failure combined with a battery backup failure. In such a scenario, the smoke detector would be rendered inoperable, leaving occupants vulnerable in the event of a fire. While this is a relatively unlikely scenario, it is a risk that should be considered when evaluating the overall safety of a fire detection system. Furthermore, the potential for interference between AFCI breakers and combination CO/smoke detectors is a valid concern. The electromagnetic signals used by AFCI breakers to detect arcing faults can sometimes interfere with the sensors in CO detectors, leading to false alarms or even a failure to detect company. This is particularly concerning because CO is a colorless, odorless gas that can be deadly. To mitigate this risk, it is important to choose CO/smoke detectors that are specifically designed to be compatible with AFCI breakers. These detectors typically have shielding or filtering to protect against electromagnetic interference. It is also important to follow the manufacturer's instructions for installation and testing. In conclusion, the decision of whether or not to protect smoke detectors with AFCI circuit breakers is a complex one that requires careful consideration of the potential benefits and drawbacks. Building codes and electrical standards should be considered along with the specific circumstances of each property and the type of smoke detectors being used. In Palm Beach County, the requirement for AFCI protection reflects a local emphasis on enhanced fire safety. However, it is important to be aware of the potential for false positives, redundancy, and interference with CO/smoke detectors. By carefully weighing these factors and taking appropriate precautions, it is possible to create a fire detection system that provides optimal protection for occupants. The initial concern that if an AFCI breaker fails and a smoke detector's battery backup also fails, protection is lost. This is a valid point. Electrical components can fail and batteries do deplete. This highlights the importance of regular testing and maintenance of both AFCI breakers and smoke detectors. Regular testing ensures the AFCI breaker trips when it should. Regular battery replacement ensures the smoke detector functions during a power outage. Diverse safety layers are better than relying on one. A hardwired smoke detector with battery backup and AFCI protection offers more security than just one or two of these elements. The best approach depends on individual risk tolerance, budget, and specific location requirements. Consulting a qualified electrician is always advisable. They can assess a specific situation, explain local code requirements, and recommend the most suitable solutions. When discussing specific products, it is important to review the specifications and suitability for particular applications to ensure that they meet the required safety standards and electrical codes. This discussion serves as educational content regarding the technology of AFCI and smoke detectors. Always consult with a licensed professional when dealing with electrical installations. When dealing with electrical circuits, always turn off the power first.